Z squared plus 9Z minus 22. So first one is factoring. This is just a basic factoring problem. I kind of believe these tests start easier and work. I gotta switch my signs. Work to the harder ones, so get the first ones right? Okay, so factoring, this does not have an equal sign on it, so we just have to factor it. So we are looking at what multiplies to be 22 and adds up to be -9. So we do the two binomials, z times z is z squared. And then we say, okay, 22 is 11 and 2. So that'd be -11 and +2. -11 times 2 would be, that's not right, is it? I had my sign switched. Did I have it right the first time? My bad. This should be plus and minus. Sorry. So it's -22 plus 9. We'll start over here. -22 plus 9. I knew I should have just took a screenshot of it. Always check that on the test when you think you get funny answers. Check to make sure you write it down right. That's what happens with computer math, right? Okay, try this again. What multiplies to be -22 and adds up to be 9, it would be +11 and -2. So +11, -2. Okay, so now you always check it at the end like I was doing. That's how I knew I wrote it down wrong. 11 times -2 is -22. 11 minus 2 would be +9. Okay, so you can FOIL it back out. Like this is a test, so it doesn't hurt. If you have time, like he was asking, you can go back and check your answer. So it's not a bad idea to like FOIL it out to check your answer to make sure you get it. All right, 4y squared minus 2 equals 7y. Double check this time. 4y squared minus 2 equals 7y. 4y squared minus 2 equals 7y. Okay. On this one does have an equal sign. You have a y squared and a y, so you got to think factoring. So the number one step is to set them equal to 0. Okay. So I need to move this 7y over to the other side. So I have 4y squared minus 7y minus 2 equals 0. Now I go through my factoring steps. Okay, my factoring steps, first thing you always check for GCF. I can't divide 4, 7, and 2 by anything. So I go to the factoring. This one has a number in front of y squared. So I need to take 4 times -2. So what multiplies to be -8 and adds up to be -7? That would be what? -8, +1. -8 times 1 is -8. -8 plus 1 is -7. And then I can come over here, and this is the way I factor a little bit differently. I do not care how you factor. Like if you want to do the factor by grouping or whatever, that's fine. But I'm going to put 4y at the beginning of both of these. 4y at the beginning of both of these, okay? And then I put my two numbers that I came up with, -8 plus 1. When you go to do it by yourself, the most common mistake is to put the 4y, or forget to put the 4y at the beginning of both of these, okay? Now that's not correct, because if I followed that back out, it wouldn't be the same. So you kind of look at your factors here. So I could divide this by 4, and I get y minus 2 and 4y plus 1. Okay. The way this always works is I multiplied by 4 at the beginning, so I divided by 4 at the end. Those will always kind of match up. And now you do have an equal sign, so I set both of these equal to 0. I add 2 to this side. On this one, I subtract 1 and divide by 4, so I get -1/4. And those would be my two answers. I guess you could plug these back in to check if you wanted to. Like this is a test, like to make sure you're getting stuff right. +8 minus 8. plus 8 minus 8 equals 0. So on the previous problem, you had y squared and a y. So you set it equal to 0 and think factoring. On this one, we just have something squared. So if you just have one thing that's squared, you want to get that by itself first, okay? So what I'm going to do is add 8 to both sides, and I have w plus 8 squared equals 8. Okay. So I have something squared equals 8. To get rid of that squared, anybody remember how to get rid of the squared? Square root. So I'm going to do the square root of both sides. That makes the square root and the square cancel out. So I have w plus 8. When I do these square roots inside an equation, what do I have to put? I have to put plus or minus, okay? You always have to put plus or minus because, remember, like 7 squared is 49, but also negative 7 squared is 49. All right, square root of 8, though, I think it'll count it right if you don't do this, but you should break it down. So the pair of 2's come out, and then there's another 2 that stays in by itself. So if you have a pair, it comes out, and then if it's by itself, it stays in. And again, that's like a good example of, well, let me finish it, then I'll say that. So to get w completely by itself, I subtract 8. So I have negative 8 plus or minus 2 square roots of 2. So in Alex, you actually have 2 answers. You have negative 8 plus 2 square roots of 2 and negative 8 minus 2 square roots of 2. The plus or minus means there are 2 answers. Just a quick way to write that. Okay. This is a good example of, like, for some reason, if it would count it wrong because you forgot to reduce down the square root of 8, okay? You had negative 8 plus the square root of 8, and it didn't give you points for it. I would probably give you full points for that because this skill is not testing your ability to simplify a radical. It's testing your ability to solve that equation. All right. 2x squared minus x minus 9 equals 0. Let's go back just a second. This one says right there to use the quadratic formula, so you know it's not going to factor. 2x squared minus x minus 9. You know it's not going to factor. This is one that y'all got to remind me of this, okay? But I will write this on the board. You do not have to memorize this. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So remind me to write that formula on the board next week. I won't make you memorize that. All right, so our formulas are ax squared plus bx plus c equals 0. That's the quadratic formula, or the general quadratic equation. So my a is a number in front of x squared, that's 2. My b is a number in front of x, so that's negative 1. And my c is a constant by itself, that's negative 9. So once you have those, now I can just take it and plug it into the quadratic formula. The opposite of b, well, b is negative 1, so b is going to be positive 1. So 1 plus or minus the square root of negative 1 squared minus 4 times a times c all over 2 times a. Now what I do to make this a little bit easier is just go figure out the radical stuff because I got all this stuff underneath here. So negative 1 squared would be 1. Negative 4 times 2 times negative 9 would be 72. Positive 72. Okay. So that's the square root of 73. So now I have x equals 1 plus or minus the square root of 73. 2 times 2 is 4. 73 is a prime number. It does not break down at all. If you could simplify, you can. But again, like, I'll probably still give you credit if you didn't. So in Alex, you do have two different numbers, one plus the square root of 73 divided by 4, and one minus the square root of 73 divided by 4. For x plus 6 is less than 2. Oh, I am going to go work another variation of this problem. All right, inequality to solve this one. This is a compound inequality, or not. No, this is a compound. It's just two separate ones. Just work each one individually. So I subtract 6 from both sides. Divide by 4. You solve this just like you would a equation. What's the one difference? We don't have it in this problem, but what's the one difference when you're solving an inequality?
You're talking about dividing by a negative.
If you divide by a negative, divide or multiply technically, divide by a negative, you have to flip the sign. That's the only difference in solving these. Okay. This problem over here, let's add 2 to both sides. 2x is greater than or equal to 10. Divide by 2. So x is greater than or equal to 5. Okay. Now, what we have to do, sorry, I wanted to see how you input the answer. Interval notation. What you have to do with this, and I would draw the picture real quick. X is less than -1 and greater than or equal to 5. Okay. There is a different variation of this problem that I'm going to have to go do in a minute. So my blue one, remember it's less than -1, so I do a parentheses. Oh, yeah, we got a tricky one to start. I put a parentheses and it goes forever to the left. Okay. I do, for my red one, it's a bracket because it's greater than or equal to, and it goes forever to the right. Okay. I would highly recommend drawing this picture real quick on this problem, because now I have the word and, right? What area is the red and the blue line both on there? Do they share a spot? No. So my answer is actually no solution, which I think they use this symbol for. Okay? Because I need something that is less than -1 and greater than or equal to 5. Well, that doesn't exist. Okay? So if you draw the picture, you can say what's less than -1 and greater than 5. It's got to be on both lines. Okay? I guess I might not. Let's say you came down and you ended up with those. We can do those same numbers. X is less than -1 or x is greater than or equal to 5. If you had or, okay, graph this again real quick. Actually, let me change this to red so I can talk about my colors. Okay, if you had or on this one, I guess I don't need to graph it again. I have my picture right there. If you have or, and I look back up here, this, if it says or, I could be on the blue or the red line, right? So for the blue line, to write that in interval notation, it would be a parentheses at -1, and it goes forever to the left, which is -infinity. Remember, the graph goes to the left, my arrow's pointing to the left, so infinity's on the left. And when you go to the left, you go to small numbers, so it's -infinity. My red line would be a bracket at 5, and it goes on forever, so I do infinity. Okay? And then you use the union symbol to say or. So if it said or on this problem, you would say it could be on the blue or the red line. So that would be your answer. Okay? There is no spot where the blue and the red are on that one. It's fine. We only have 10 problems, so I won't talk for very long today anyways. I mean, I'll talk as much as y'all want me to. Let's say you work it down to the bottom and you get x. I got to think of one here. What'd I do? All right. I think I can do this both ways with this. Man, I forgot to change that to red. All right, 6 and 10. 6. All right, x is greater than 6 would be a parentheses because it's just greater than and it goes forever to the right. X is less than or equal to 10 would be a bracket because it's less than or equal to and it goes forever to the left. Okay? I'll say you draw your picture and you get this. It's the word and, so I want to know where my red and my blue line is. The word they use there is intersect, actually, and an intersect go along. So it's where the lines intersect. So my answer here would be from 6 to 10, we have the red and the blue line. This is why I highly recommend drawing this out on this one so that you can see where they overlap, where they intersect, or you can think about or and. Okay. The only other variation I can think of off the top of my head right now is, let's do that same problem. But or. Nah. Well, I might do one more variation then. This one, if it says or, I can just look at that graph that we have up there. I'm anywhere the red or the blue line is, right? Well, the red line is over, the red line is over here. They're both right here, so that counts because if I ask you if the red or the blue line is there, you'd say yes, right? And the blue line goes over here. So anybody know my answer? It's all real numbers, which I believe you would write, since we're doing interval notation, negative infinity to infinity. I don't think they have the symbol there for that. No, you would do negative infinity to infinity. Since we're reviewing anyways, we might as well try to hit all the variations I can think of. Yeah, we can do it both ways. That's fine. Why do I keep choosing 6? We'll just do 2. That's fine. All right, so when I go to graph this one, I have my blue line is less than or equal to, so I do a bracket forever to the left. My red line is less than or equal to, so I do a bracket, and it's less than or equal to, so I go forever to the left. Okay, again, I'm doing a bunch of different variations because I know this problem gets tricky with the different variations. Most problems aren't going to have this many variations on it. But if you just draw the picture, it makes it so much easier. So I'm looking at and. I want to know where the red and the blue line are. So that would be what, right here. And I would do from 2 to negative infinity. Sorry. All right. All right, variation number 5 on this one. Hopefully this is the last one. All right, red or blue. So on this one, I could be anywhere the red or the blue line is. So all I have to do on this one is from 6 to negative infinity. And that would include everything that's on the red line, right? Because the red, all of the red is on the blue. So that would include all of them. I think that's all the ones that I can come up with off the top of my head. All right. On to the next one. F of negative x plus f of x. Negative 5x plus 5. On this one, there's a graphing problem. Even though it has a function notation, this is like y equals mx plus b. Okay. My m is negative 5, which would be negative 5 over 1. So it's negative, so I go down 5 to the right 1. And my y-intercept is 5. This is my starting location. One, two, three, four, 5. So I'm going to start at my y-intercept, which is 5. And then I do what my slope says. My slope says to go down 5 to the right 1. Positive, you go up. Negative, you go down. The bottom number always tells you to go to the right. So that's why I rewrote this as a fraction right here. I rewrote it as a fraction right here because you want that rise over run. Positive up, negative down. The bottom number tells you how much to go to the right. So now I can draw my graph. And got that one done. 0, 5 was my starting spot, and then I went down 5 to the right 1. Pausing for a second, make sure everybody. Let me try to do this without messing this up. Maybe we can just screenshot this. Yeah, all right, at least zoom in. Okay. Don't miss the easy questions like this one right here. Does the parabola open upward or downward? Okay. It obviously opens upward. Whoops. Opens upwards. Makes a U, so it's upward. If it's down, it'd be upside down U. Find the coordinates of the vertex. The vertex is where it changes direction, where there's like a stopping point. So it changes direction right there. So this would be at 2, 8. 2, negative 8. 2, negative 8. Find the intercepts. My intercepts are where it crosses the x and y axis. Okay. So at x, it's negative 2 and 6. And at y, it's negative 6. Okay. So there's my intercepts, vertex, x-intercepts, y-intercept. What else do I got to find? Find the equation of the axis of symmetry. I was scared right when I wrote that I was going to ask me that. Now I got to move these. Okay, my axis of symmetry, you can actually just look at the vertex if you want to. But the axis of symmetry is where it folds in half. So it folds in half right here. This is a vertical line, so it's x equals 2. It is always going to match up with your vertex number. Okay, it's always going to be whatever your x is on your vertex number. So you don't even have to think about that line really, because you do have to write x equals 2 because it is a vertical line. But you don't have to even think about the vertical line. Just put x equals 2 because that's what it does on your vertex. Okay. The vertex tells us a lot of information. It tells us the axis of symmetry. So the folding point tells us where it changes direction. It tells us our minimum or maximum. So on this one has a minimum, right? It has a bottom point. So that's the lowest number of the graph. Okay. All right, number 8. -2 x plus 5 squared plus 1. What number did I say this was? 8?
Yep.
Number 7. Okay. Now I forgot what it was. -2 plus 5 plus 1. -2 plus 5 plus 1. All right. So graph this. It says to vertex 2 points to left, 2 points to right. Okay. So the first thing is the vertex. My formula for this is not something that I will give you on the board because this is just something that you should probably recognize. Oh man, am I going to be nice? I will write the formula, but I will not write the next part, okay? I will write that formula. So the formula starts out with a negative right here, right? So my vertex does not account for that negative. My vertex is just HK, okay? So I will write this, but I won't write that the vertex is HK, okay? You got to memorize, you got to know that. So what that means is and this is going to happen after the test. I think it's the section after the test. After the test, we talk about transformations, and anytime you are inside, you always think opposite. So my vertex is not +5. My vertex is actually -5, +1. Okay? The K is normal. When you're on the inside, you always do opposite of what you think. But on the outside, it's always normal. Okay? And that'll hold true after the test. I'm not going to go into that too much, but I use that same thought process. What did you say?
If it's -5,
If it was -5, you would put +5, yes. Because this formula starts with a negative, and all I'm looking at is this right here. So if I had, 3x minus 2 plus 6, my vertex would be 2, 6. Okay? So on the x, the inside's always opposite. Okay. All right. That is my vertex. So if we want to go ahead and graph that, we can, just so we can see it. -5, 1. 1, 2, 3, 4, 5. +1. -5, 1. All right. From there, we have to find 2 points from the left and 2 points on the right. We're going to use symmetry to make our life easier here. That wasn't very straight. So if I put my vertex right here in the middle of my little chart, now I need to find 2 points less than that and 2 points greater than that. I would just use the 2 right next to it. So I want to find -4 and -3, and then -6 and -7. Okay? So I'm going to start plugging these in. I always try to plug in the smaller ones, but plug in 2 numbers to the left or 2 numbers to the right. I'll show you why in just a second. So when I plug in x equals negative 3 to this equation, I get y equals negative 2, negative 3 plus 5 squared plus 1. That would be negative 2 times 2 squared plus 1, negative 2 times 4 plus 1, negative 8 plus 1, y equals negative 7. Okay, go ahead and plug in. Wait, which way does this one open? It does open down because that's negative, right? So that does make sure, a little check to make sure you did it right. Now plug in negative 4. So y equals negative 2 times negative 4 plus 5 squared plus 1. That would be negative 2, 1 squared plus 1, negative 2 times 1, negative 2 plus 1, y equals negative 1. Okay, if I go plot these points, negative 4 is at negative 1. 1, 2, 3, 4, 5, 6, 7. Negative 4 is at negative 1. And negative 3 is at negative 7. I have the right side of my graph. Okay? Thought I was drawing that good. I have the right side of my graph. You can go ahead and plug in negative 6 and negative 7 if you want to. If you forget this next part, just plug in negative 6 and solve it just like I did. Plug in negative 7, solve it just like I did. That's fine. But everything is symmetric on these graphs. So these will be the same. So I know that if I go 1 to the right, I went down to negative 1. If I go 1 to the left, I'll go down to negative 1. If I go 2 to the left, or 2 to the right, I went down to negative 7. 2 to the left, I go down to negative 7. So everything is symmetric on these. Changing some colors to make it. The green's kind of hard to see, but so you can just use symmetry, or just if you forget that, just plug them in. But it will always match out like that. That's why I always go 1 to the left, 2 to the left, and then go 1 to the right, 2 to the right. So that'll make it easier to use the symmetry. I'll pause for a second. Whoops. Let's see what number 9 is first. Oh no, did it reload on me? That's fine. Oh, I gave you the easy one. I didn't give you the hard one on the graphing. That's fine. Negative 5x plus 7y equals 10. Negative 7x minus 3y equals 14. Double checking real quick. Negative 5x plus 7y equals 10. Negative 14. All right. System of equations. We want to find the one point that works for both of these. That is the intersection point. The easiest way to do this is the way your problem is going to set up too, is to use the addition or elimination method. So do we want to cancel out the x's or the y's? What'd you say? Y's? The x's? Did somebody say the y and somebody say the x's? Does not matter.
Y's are easier because they're already negative, or they're opposite, right?
That is probably so. We'll do the y's because it is easier when one's positive, one's negative. Like you're less likely to make a mistake if one's positive, one's negative. What is the common number between 5 and 7? 35. Okay, so I'd have to make one positive 35 and one negative 35, right? Whereas these are already, one's positive, one's negative. So what's my number I'm trying to do here? 21y, positive 21y, negative 21y. So to get 7 to be 21, I'm going to multiply everything in here by 3. 3 times negative 5x is negative 15x. 3 times 7y is 21y. 3 times 10 is 30. Do not forget to multiply that last thing. Okay, you got to multiply everything in here. And then to get negative 3 to negative 21, I'm going to multiply by 7. So 7 times negative 7x is negative 49x. 7 times negative 3 would be negative 21. 7 times 14 would be 98. Now when I add these up, negative 15 plus negative 49 would be negative 64. My y's cancel out. And then 30 plus 98 would be 128. So now I have a very basic equation, and I just have to divide both sides by negative 64, and I get x equals negative 2. You should get an integer here. If you get a fraction or a decimal, you probably did something wrong. Okay? Alex always gives you normal numbers to work with. Once you get one number, you plug it back in to find the y or the other variable that you're looking at. So I'll plug it in. You can plug it into the top or the bottom. It does not matter. I'll plug it into the top. So I get 10 plus 7y equals 10. Subtract 10 from both sides. 10 minus 10 is 0. 0 is a number. That is fine. Okay? So these intersect at the point negative 2, 0. And the last one is a system of linear inequalities. Y is less than negative 2x plus 5. Y is greater than 4x minus 3. Make sure 4x minus 3, negative 2x plus 5. Okay. Graphing this is very similar to graphing y equals mx plus b. There are two differences. The first difference is if it is less than or greater than, you do dashed. If it's less than or equal to, you do, or greater than or equal to, you do a solid line. And then the second difference is you need to shade. Okay. So my top line, I'm just doing y equals mx plus b. My m is negative 2. So that's negative 2 over 1. That would be down 2 to the right 1. And my y-intercept is 5. So I start at my y-intercept, and then I go down 2 to the right 1. And I have my graph. Oh, wait, this is dashed, isn't it? Don't forget that. I almost forgot. This is dashed because it's less than or equal to. Okay. Now to shade this, sometimes you can look at it and say, okay, it's less than, so I should shade down here. But if you need to, and you might need to, that's fine. For shading purposes, you plug in a point that's not on the line. So if I plug in 0, 0, 0, 0 is always the easiest one to plug in if you can. You just can't plug it in if it's on the line. Is 0 less than 5? That is true. So I shade towards 0, 0. Okay? So I'm going to shade this way. I'm just going to put a little arrow right here to remind me that I'm going to shade down there. Now the other line, my slope is 4. So that's 4 over 1. That would be positive 4 up 4 to the right 1. And my y-intercept is at negative 3. This one is also dashed because it's greater than. So I start at, oh no, don't want to erase. Start at negative 3. I go up 1, 2, 3, 4, and to the right 1. Draw my dashed line. Okay. This is the one where it's harder to figure out where to shade. It's greater than, so when you shade above it, it's kind of hard to like look at and tell. So again, make sure you plug in 0, 0, or make sure it's not on the line. I don't think 0, 0 usually is on the line, but 0 is greater than 4 times 0 minus 3. 0 is greater than negative 3. That is also true. So I shade towards 0, 0, so that would be this way. So I need to be below the red line, above the blue line, so my answer shading would be this area right here. And just because I'm on the iPad, let me show you this. What's your true answer here, and I may delete this in a second, is my red shades over here, my blue shades over here. So my answer is actually the intersection of the shading. Okay, my answer is actually this area right here.
Do you think Alex is going to be mean to us and throw us one of the circular circles or parabolas at us like this?
No, that topic's not on here.
Okay.
Did they do circles?
Yeah.
There were circles on there?
Yeah.
Oh, what does it
Squared
mean?
plus y squared equals like, or less than or greater than 9, yeah.